All right, this is page 37 of math analysis, and we're going to talk about trig and lines. So what does this have to do with trig, or what does it have to do with lines? Let's find out. So first of all, points on the unit circle associated with pi over 6, pi over 4, pi over 3. So how should we write this? I'm going to write, I guess, like pi over 6, and then maybe a colon. And then I know the cosine, or just picture the circle, which is actually what I try to do. So I try to picture like unit circle, and then I'm like over far on the right-hand side, but I'm not like at 0. So it's like the farthest x you can have basically is radical 3 over 2, and then the y has to be 1/2. That's how I try to picture that. Pi over 4. That one I know is, they're the same. Okay, and then pi over 3. Once you get pi over 6, you can't get pi over 3 wrong because you just reverse them. All right. State the tangents. All right, so the tangent of pi over, there's a lot of like recalling stuff here. Root 3 over 3. The tangent of pi over 4 is 1, and the tangent of pi over 3 is root 3. So these are all things we should have memorized at this point, and fortunately, I do. All right, find the equation of the line through the point associated with pi over 6 and the origin. Okay, the point associated with pi over 6 and the origin. All right, so here's like a really big idea. So I know that it goes through the origin, 0, 0. I know that it goes through radical 3 over 2, 1/2. So the slope of this line is going to be, well, the change in y over change in x. So 1/2 minus 0, root 3 over 2 minus 0, which is going to be 1/2 over root 3 over 2. But that's just 1 over root 3, which is root 3 over 3. And take a look at that. So the point we're dealing with, pi over 6, this is the slope that we got, and it's just the tangent of the angle. So the question is going to become, like, is that always going to be the case? And if it's the case, what can we do with that? So I'm going to write in point slope form, but I'm going to use 0, 0 as my point. So we get this. Or I guess you could simplify that and just say y equals radical 3 over 3x. Probably better to do that. I'm not going to. Let's do pi over 4. So let's see if this continues. So 0, 0 for sure. Root 2 over 2, root 2 over 2. So the slope is changing y over change in x. So root 2 over 2 minus 0 over root 2 over 2 minus 0. There you go. Perfect. Again. So again, we found a slope of this for pi over 4, and that is the tangent. So this keeps happening. And, I think it's going to keep happening because it kind of makes sense. So we're doing like change in y over change in x, but because of the way the unit circle works and we're going through the origin, the change in y is actually just the sine of theta, and the change in x is actually just the cosine of theta. It's just the y coordinate and the x coordinate. So you're doing y over x, which is just tangent. So I think it makes sense that we're getting these results. And like maybe going into this, you were like, isn't it obviously going to be blah, blah, blah? Maybe, but maybe it's not obvious to everyone. And it's, I think, a worthwhile pursuit to see if we can confirm some of these things. So here, minus 0, 1/2 minus 0 gives me just root 3, which is exactly what I was expecting again. So I guess I'll highlight it again. Pi over 3. So we just get tangent of the angle. So this means that if we know the angle that the line is forming with the x-axis, we can write the equation of the line, or at least the slope of that line, by taking the tangent of the angle. So that's a pretty cool thing. So this would be, so you want to get used to using point slope form, because once you get to calculus, it's all you're going to use, right? Unless somebody gives you specific directions of something else that you should use, you're going to be using point slope form. So just get used to it. Explain the relationship between your answers to the previous 3 questions and your answer to the second question. Okay, so I'm going to say, I guess I should start with the slope of the line is the tangent, which I'll abbreviate tan with a period, of the angle formed with the x-axis. I think that is a good explanation. Full sentence, right? If somebody asks you to explain something, you should use a full sentence. So The slope of the line is the tangent of the angle formed with the x-axis. All right, so that's my explanation of that. For each of the lines you found in question 3 through 5, the angles pi over 6, pi over 4, and pi over 3 are called the angles of inclination, so that seems important. Angles of inclination, which like a lot of people confuse with the angle of elevation. I don't really know like how painful a confusion that is. I bet there are a lot of people who don't know that angle of inclination is even a thing. But explain the relationship between the equation of a line through the origin and its angle of inclination. You'll need this in calculus at some point, and you'll claim you don't remember. Yes, that's definitely true. So what are we doing here? So I'm going to say that let's say if theta is the angle of inclination, I probably should not abbreviate that. Inclination, then the slope of the line, whoops, the slope of the line is the tangent of theta. Okay, not a problem. So yeah, you're definitely going to need that. So you'll have m is equal to the tan of theta. In Calc 2, we do parametric stuff, and you talk about like the angle at which something like hits the water or the whatever, and you always have to do like the inverse tangent of the slope, because it turns out that it's easier to find the slope of that line than it is to find the angle. So we'll find the slope, and then we'll be able to find the angle by doing the inverse tangent of the slope. So it's really, we're going to end up using it backwards when we do use it eventually in calculus, but you got to know it, right? So then this question, does a vertical shift change the angle of inclination of a line? So I'm going to go with no, like it definitely does not. Let's draw a picture. This is actually one of the things from geometry that just keeps coming up. And it's the fact that, let's draw our line. Oh, well, I mean, should I draw like a perfect line, as in let this do it for me? Okay, there we go. And I'm going to draw some other lines. So if I shift it, because the line can't tilt, it's not going to change the angle at all. In fact, you don't need to use the x-axis. You can just use, what color should I use here? You can actually use any horizontal line, because these are all parallel lines cut by a transversal, so corresponding angles are congruent. So the answer to this question is no. Shifting it up or down doesn't change the slope at all. So shifting up / down, which is a vertical shift, or I mean a horizontal shift also isn't going to change it, but in this specific case, shifting up down does not change the angle. And I think that's good enough. I mean, we don't need to belabor this point. Not a big deal, but it's like a nice geometric connection. And I just wanted you to make sure, that you were aware of it, because I don't want there to be anything happening that you are unaware of. So I'm going to stop this video here. I'm going to come back in the next one, and I think we are starting the next set of notes. So that's pretty exciting, and I hope to see you there. So I will see you there, hopefully. Anyway, hope you're finding these helpful, and yes, I will definitely see you there.